Hi, welcome to Advanced Physical Science. This is Chemistry Unit 3, 3.1a on chemical bonds. Today we're going to be talking about why atoms combine, characteristics of compounds, oxidation numbers, types of bonds, and ionic transition bonds. So why do atoms combine? Well, most of the matter around you is in the form of compounds, not individual atoms. The properties of a compound are very different from the properties of the elements that make them up. A chemical bond is actually a force that holds together the atoms in a compound. And chemical bonds form when atoms lose, gain, or share their electrons. So let's look at the characteristics of a compound. You're going to have the symbols that you're very familiar with. With those symbols, by putting those symbols together, you're going to be writing formulas. Notice that some of these formulas have subscripts. And those numbers, those subscripts, tell you how many of that particular atom go into that compound. So it's kind of like an exponent in math. It comes behind the letter, not in front of it. And finally, we're going to talk about the ratios. The ratios of compounds for things like H2O is 2 to 1 because there are 2 hydrogen atoms to 1 oxygen atom. Again, just like in math, if there's one of something, we don't write it down, we just write it down. We don't write that there's one of it. So oxidation numbers, the numbers of electrons that would like to gain or lose to complete the outer valence shell. And all atoms want a complete outer shell, and it's called an octet because 8 electrons will complete any outer shell. And they come from the valence electrons. So you already have the group numbers and you already have the valence numbers, and hopefully you can add the oxidation numbers. The oxidation numbers go above the valence and come from the valence in a sort of way. Oxidation or valence of 1 has an oxidation of 1 positive, 2 is 2 positive, 3 is 3 positive, 4 is plus or minus, because it's just as easy for 4 to join 4 as it is for 4 to join 4. A valence of 5 has an oxidation of 3 negative. 2 or 6 is 2 negative, 7 is 1 negative, and a valence of 8 has an oxidation of 0. Now, those valence numbers 1 through 3 want to lose to become stable. That's why they're positive. But a valence of 5 through 7, they want to gain to become stable. That's why they're negative. And a valence of 4 can go either way. So hydrogen, lithium, and sodium have oxidations of 1 positive because they would like to give that 1 extra electron away. While at the same time, fluorine, chlorine, and bromine have oxidations of 1 negative because they would like to get 1 electron to become stable. On your periodic table, you want to add what's called the border, or it's also called the stair step. And it goes down the middle of your metalloids, separating boron from aluminum, and then literally down the middle of your metalloids, to separate and show that everything on the right-hand side of the stairs, including hydrogen, is considered non-metal for bonding purposes. And everything on the left-hand side is considered to be a metal. So we actually just split those metalloids kind of in half, and we share them. We get 3 metalloids that act like metals and 5 metalloids that act like non-metals. So there are really 2 types of bonds, and today we're going to talk about one specifically, and that is ionic. Ionic bonds are where electrons are lost and gained between the atoms. They occur between metals and nonmetals, and they will use the oxidation numbers. Tomorrow, we're going to talk about covalent, where the electrons are shared between 2 nonmetals, and you have to be given how many you're going to use. And again, for bonding purposes, everything to the right is a nonmetal, and everything to the left of the stairs is a metal. So let's look at some perfect ionic compounds. If we wanted to combine sodium and chlorine, sodium has an oxidation of 1 positive, chlorine has an oxidation of 1 negative, and to write the formula, you literally just put the 2 symbols together and write NaCl. No spaces or gaps to show that this is a formula instead of individual atoms. Same thing with potassium and bromine. Each have an oxidation of 1. They would combine to be KBr. Now, magnesium and oxygen, they go together in a slightly different way because magnesium is an oxidation of 2 positive and oxygen is 2 negative. So we could write the formula as simply MgO. Same thing with calcium and sulfur could be CaS. We're going to talk more about those. Potassium and oxygen. Now, potassium has an oxidation of 1 positive and oxygen has an oxidation of 2 negative. So how do those two go together? Well, the oxidations actually crisscross. The 2 from oxygen comes down to be with potassium, and the 1 from potassium comes down to be with oxygen, and we write the formula of K2O. That's where those numbers, those subscripts, come from. That means it requires 2 potassium to combine with 1 oxygen. Again, calcium and chlorine. Calcium is a 2 positive, chlorine is a 1 negative. The 2 from calcium comes down to be with chlorine. The 1 from chlorine comes down to be with calcium. And just like in math, we don't always write the 1s, and we would write the formula of CaCl2. It's okay to write Ca1Cl2 until you get used to it, because it would take 1 calcium to combine with 2 chlorine. Things to notice: if the subscripts were to match, we leave them off. However, keeping the subscripts like Mg2O2 would make a molecular formula, but taking them off writes an empirical formula, and you'll be learning more about that in the reading. The positive oxidation always comes first, and you do have to pay very, very close attention to capital, lowercase, and the placement of subscripts. They do need to be subscripts and not just written behind, because that could get confusing in a couple days. Now let's look at those transition elements. Transition elements gets their name because they have variable oxidation numbers. And their oxidation numbers, remember, are always positive. And you have to be told which one you're playing with. So notice, and you saw this in your scrapbook if you had a transition element, that it had more than one oxidation. And you have to be told what it is with a Roman numeral. And these will form ionic bonds with other elements and compounds. For example, if I wanted to combine copper 1 and oxygen, that's Cu1 positive and oxygen is 2 negative always. The 2 comes down, the 1 comes down, and we write the formula Cu2O. Iron 3 and chlorine would be Fe3 positive, Cl1 negative. They crisscross, the 3 comes down, the 1 comes down, and we write the formula FeCl3. On your formula sheet, you want to fill in the ionic rules for bonding. First rule is a metal and a nonmetal. Second rule is they use the oxidation numbers. Third, they use the crisscross method. And finally, part of that crisscross method, the transitions have to have a Roman numeral. Thanks for watching.